Happy welcome. All right, so if you stumbled across this, so you either are searching out for Mohnish Pabrai, maybe you have taken on his little math challenge, which he gives to his Dakshana students. So they're written out in red. Now, Mohnish, okay, so there's a picture. I'll just pop the picture up above there. Is basically a value investor. So he's kind of like he loves to copy Warren Buffett. Is almost puts Charlie Munger as one of his gods. So I certainly try not to do that, but I do admire Warren Buffett and Charlie Munger for certain things, not for all the things that they stand for. But in terms of value investing, I think they definitely do have quite a powerful niche behind them. Now, this particular problem is interesting because Mohnish has given this to his students, and it has been outlined by William Green in the book Richer, Wiser, Happier. Okay, so that's the actual book, and again, somewhere on the screen I'll put up a picture of that book. So as I was reading this book, this caught my attention. In this channel, I pretty much put up videos which are foundational to math, but I actually haven't run into this problem, so I just kind of stopped reading and then tried to basically prove what Mohnish was putting out there. It turns out that when he, at least at the time that he gave it to his students, somebody was able to solve this within, I think, 10 or 15 minutes, which is pretty impressive. And that student was supposedly about maybe 15 or 16 years old. So I certainly wouldn't have been able to solve this at 15, 16. My IQ level isn't that high to be able to pick these things off, and I didn't have enough of a background. But now, this intrigues me because I do teach mathematics, and, I thought that it was kind of a fun little puzzle. So let's break this thing down, and I apologize to Mohnish, so if you ever do watch this, so I'm sorry, Mr. Pabrai, because I guess I'm spoiling your little game, okay, that you give to your students, so maybe you're going to have to find some other challenge, okay, or you can still continue with this one, if they never ran into the solution before. So here it is for those who are actually interested, maybe read the book, or just love to tinker with these little math puzzles that we are given sometimes. So Mohnish says this. So he says, let n be greater than 5, okay, or sorry, greater or equal to 5, and let n be a prime number. Now, you, of course, have to have knowledge of what prime numbers are. So prime numbers are basically the set of numbers, so they are belonging to natural numbers. Natural numbers are just counting numbers. So 1, 2, 3, 4, 5, okay, so counting. They keep on going. And natural numbers have a particular nice kind of essence to them, that if you continue with these prime numbers, so these are all the prime numbers, they go on forever, you'll notice that they are only divisible by 1 or by themselves. Now, if you want, some more detail, I'll put up a link up above there to prime numbers if you want to prime yourself, okay, so for this. But those are prime numbers. Now, he's saying that we're starting from 5, okay, and then we're going onwards. So 5, 7, 11, I guess there'll be 13. 17, 19, and so on. So those are the prime numbers. Now, all he's saying is that, well, if you take any of those prime numbers, you square that prime number and you subtract 1 from it, it should be divisible by 24. That's what we want to be able to prove. And that's not very easy to do, actually. Okay, so it just depends on how much knowledge you have. Now, I like this problem quite a bit, because it challenges us on several different fronts. Now, the way that I'm going to break this problem down, or this particular proof of this, okay, is in the following sense. So first of all, so what I'm going to do is, okay, I'm going to say the following, that n squared minus 1, okay, so for this, is, okay, supposed to be divisible by 24, okay? Now, 24, okay, so if you notice, so if I can break 24 down, okay, it's nothing else but 8 times 3, right? So the idea is that we want to be able to show, at least this is what I'm going to do, is I want to be able to show that n squared minus 1 is divisible by 3, and it's also divisible by 8. Now, if I can show that, then it shows that it is actually divisible by 24. So that is interesting, okay? Now, let's start, okay, so first of all, with divisibility by 3, okay? So if you take, okay, so if I'm going to take n squared minus 1, and I ask, is this divisible by 3? So the answer is yes, and it actually falls off through kind of a simpler identification, nothing to do necessarily with prime numbers, but n squared minus 1, so this is a difference of squares, which you can rewrite as n minus 1 times n plus 1, okay? So if you would distribute that across, this is just equal to n squared minus 1. Now, the reason why I am separating, okay, this into 2, because of the fact that I'm going to show that one of these, so either n minus 1 or n plus 1, is divisible by 3, okay? And what I know, okay, so this is just a fact, that if I multiply this by n, so I'm going to get n multiplied by n minus 1, okay, and then it's going to be n plus 1. Then what I have is, okay, I have the multiplication of 3 consecutive natural numbers, okay? So 3 consecutive natural numbers, because I can rearrange this and say n minus 1, multiplied by just n, multiplied by n plus 1. So these are 3 consecutive natural numbers. And it turns out that the multiplication, okay, of 3 consecutive natural numbers, one of these is always divisible by 3. So that's a fact, okay? And I, you know, for those who are really interested in that, I'll put up a link up above there because I did a video, okay, with regards to that. Now you might say, well, but I want to make sure that it's divisible by only these 2. Well, that falls apart from the fact that n, okay, within Pabrai's given information is prime. And for prime, that means that this n is only divisible by n and by 1. So that means the 3 consecutive natural numbers that I have in here, okay, if one of them is divisible by 3, it's either this one or this one. It can't be n because Mr. Pabrai has said that, well, it's prime. Okay, so therefore, so that's the first thing. All right, so that means that I can, okay, divide, okay, this by 3 by simply knowing, okay, that if you take 3 consecutive natural numbers, one of them is always divisible by 3. So that's a fact. And I show that in the link that I provided. So that's 1. So now this leaves me with the second item, which is this right here. Okay, so that means is n squared minus 1 divisible by 8? Well, so once again, so this kind of borrows from another nice idea. And it turns out that for any n which is odd, okay, and this is assuming that n is actually, you know, greater than 1, so that means it's either 3, 5, 7, 9, and so on. So I'm not saying that, you know, n is necessarily prime, but it's actually less restrictive. It's saying that for n, which is an odd number. So for any odd number, okay, if n is any odd number, it turns out that n squared minus 1 is always divisible by 8. Okay, so once again, so I do show this, okay, and I don't want to convolute this particular video, okay, so I'll put up a link up above there. It's a short video, okay, if you want to see that for any odd number, okay, n squared minus 1 is always divisible by 8. And now, is n odd in our case? Yes, it is, because again, so Mohnish said that n is prime. And it is greater, okay, or equal to 5. Well, so any prime number, which is 5 or above, is always odd. And it can't be even, because if it was even, then it's not prime, because it would be divisible by 2. So given that information, okay, we know that n squared minus 1, if n is prime, is always divisible by 8. And we know that, okay, n squared minus 1, as long as n is prime in this particular case, okay, then, okay, that n squared minus 1 is going to be divisible by 3. So if it's divisible by 8 and if it's divisible by 3, then 8 times 3 is 24, which basically proves what Mohnish was saying. So indeed, you would have to look at the two double links there that I showed you for those. And I don't want to reproduce this in here because I think those videos have, essence on their own with regards to odd numbers and then 3 consecutive natural numbers. Okay, so I just kind of deal and prove that directly. Okay, and then you can apply it to Mohnish's problem. Now, Mr. William Green, said that this would forever elude him. And if he ever does watch this video, I would be more than happy to try to go through this content with him so that he can realize that, hey, this is not beyond him in any way. So, when the students come into my math classes, I always want to say that I want to try to do the best I can so that they walk out and actually understand where the answers are coming from. For anyone with some math knowledge of prime numbers, okay, then the explanation might actually do. But if you want a little bit more, and if you found those links that I gave you didn't provide you what you needed, give me a shout out, okay? Thank you, Mohnish, and I'm sorry I have, ruined your little challenge for your students, but it was great to see it in the book, okay? I wish you and Mr. Green all the best, okay, in the future. Thank you for sharing this, and thank you for all you do. Bye, everybody, okay? Take care.